And the title of my talk is From Representation to Social Construction, the Metaphysical Basis of Participatory Realism. It seems a bit ambitious, but it's only a first approximation. Before starting, although they are not here now, I want to thank the organizers for inviting me to come to this wonderful place. I want also to dedicate this talk to honor the memory of a colleague in the philosophy department in Oviedo University called Gustavo Bueno that passed away last August. And I'm going to use some of his ideas, although only I am the responsible for the use I'm going to do. My talk will be organized as follows. First, I will make a brief introduction, stating my position. Then, I will explain what I understand by transcendent realism. Then, I will explain also briefly my understanding of the essential quantum mechanics principles. And then, based on the previous part, I will make a proposal for a metaphysical frame for quantum theory, putting emphasis in the role of the subject, and then I will finish speaking about how the ideas of objectivity and truth enter in this framework. Well, there is almost general acceptance that quantum mechanics is perhaps the best scientific theory we have ever constructed. It is said that it is the support of at least 25% of current economic world gross product. Its practical success and its impact in our lives is beyond precedence and discussion. Without question, it represents one of the greatest triumphs of science. However, and after 90 years, the discussion about how to understand some basic elements of the formalism and the nature of reality that quantum mechanical formalism implies is still very alive. In our opinion, the main reason for the difficulties lies in the realist common sense intuition that has its origins in classical mechanics and it still permeates our society. This common sense is incompatible with the postulates of non-relativistic quantum mechanics. Due to this adherence to classical mechanics, many physicists and philosophers have been and still are receptive to the so-called quantum conundrums, well known to all of us, like the measurement problem, the physical collapse of the wave function, non-locality, EPR paradox, and so on. In fact, none of those paradoxes exist inside quantum theory. They only exist if you try to maintain the old classical picture. The classical conception is so resilient that many scholars try to adapt the understanding of quantum theory to this conception of the world, forgetting that, first, classical physics was empirically refuted, and second, that quantum mechanics was contrived to solve the problems against and despite it. This useless attempt of keeping the classical vision of the world is an artificial inversion that puts fundamental difficulties in the normal process of conceptualization. My approach, goes in the opposite direction. I will dispense with the metaphysics of the classical conception and I will accept quantum theory as set by 1927 by the Song of the Founding Fathers, Bohr, Heisenberg, Jordan, Pauli, Bohr and Dirac between them, sketching an understanding on how the world may be considered if we consider non-relativistic quantum theory correct. Galileo said that he could not sufficiently admire the outstanding perspicacity of the heliocentric astronomers who, through pure force of the intellect, preferred what reason told them, that is, the mathematical language, to what sensible experience showed them. I will follow Galileo's advice. I could not sufficiently admire the outstanding perspicacity of the founding fathers, and I will support my arguments on the mathematical language introduced by them. Transcendent realism. The success of classical mechanics gave way to a scientific revolution and, as a consequence, to a big economic and intellectual human development, the Industrial Revolution initiated in the late 17th century. The philosophical movement related to classical mechanism was the culmination of a long journey dating back at least to the origins of our Occidental civilization, usually ascribed to ancient Greece. The gnoseological aim of mechanism could be summarily characterized with Galileo's assertion that the universe is like a book open in front of our eyes, which anyone can read. This same idea of in front of us, of detachment, has been repeated ad nauseam today by the realist scholars working on the foundations of quantum mechanics, philosophers of science, and so on. By the end of the 19th century, and after a long process of elaboration, mechanism was a close, coherent, epistemologically and strong and well-structured view. Today, the force of this conception cannot be underestimated. It is still the common sense conception of the world in which the intellectual elite think in all branches of knowledge, and it is the reference in all sciences, modulo quantum physics. For both the academic and the man on the street, the detached external world is composed by corporeal objects, that is, pieces of matter, that at a certain time are characterized by the definite values taken by a few measurable properties. As all you know, this is called realism. Realism in the restricted sense, I will call it. This occurs at any scale, from electrons to the entire universe. In the mechanism conception, this multiplicity of detached objects are seen as given to us in our actions. Physical reality has nothing to do with our previous activity, with us, and therefore the task of sciences and scientific theories can only be to reflect or to describe or to adapt our knowledge to the open book that has been given to us, depending, of course, on your methodological approach. Many scholars are so fastened to this view that they seem to be unable to think outside this scheme. But since the beginning of the 20th century, we know for sure that classical theories that gave way to that powerful conception of nature that worked satisfactorily for 3 centuries failed empirically. Only one example is enough. They were unable to explain the stability of matter and therefore our presence here. And an empirical refuted theory cannot be the basis to build up any satisfactory conception of the world. It could be useful only for practical purposes, nothing more. Summarizing, the origin of the so-called conceptual difficulties in the foundations of quantum mechanics and of all mentioned conundrums is not really in quantum theory, but in the attempt to keep classical realism at any price, even if the price to pay is a theory as successful and beautiful as quantum theory. Today, it can be said that the defenders have failed for 90 years. In what follows, I will explain what quantum theory conceptually implies and how to conceive physical reality according to this understanding. I will state now my position on quantum theory, briefly, and I call it, or I have called in my papers, the conventional interpretation of quantum mechanical formalism. The acronym, of course, coincides with Copenhagen interpretation. Before starting, let us remember Bernard d'Espagnat's repeated idea. The postulates of non-relativistic quantum theory are general principles of physics. They must be satisfied also in quantum field theory and even in string theory. And I agree with d'Espagnat, and I will base my arguments on those postulates. As I have said, these principles were established under the mentioned empirical pressure by the founding fathers, and by 1930 we could say that the foundations of the theory were practically closed. The foundation fathers knew perfectly well classical physics, and they understood its inability to advance, that is, to explain the results of many experiments that are not necessarily to remember now. They built up a new theory able to overcome all the empirical difficulties. This was a great achievement that should and will be recognized in the centuries to come. By the conventional interpretation of quantum mechanics, I mean the theory included in almost any textbook on quantum mechanics. For example, Cohen-Tanucci, Galindo and Pascual, Medbacher, Sakurai, the other books that I'm using in my classes. Some of these principles are stated as follows. Postulate 1. To each physical system that is intended to be described in the framework of blah, 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 is made to correspond a Hilbert space and so on. A pure state of the system at an instant of time t is represented by a unitary ray. An element of the ray is called a state vector or a ket. We can use alternatively the formalism of the density matrix. Postulate 2, it's observable of a physical system, is represented by a self-adjoint linear operator. The only possible result of measuring an observable is one of the eigenvalues of this operator. Postulate 3 is Born's rule. Postulate 4 gives us how to get the new state, the collapse, and so on. Okay. The only purpose of bringing up these principles is this. Tacitly, these postulates contain, first, that there are systems studied by subjects that decide what a system is. I will say that I will call this idea realism in the broad sense to distinguish from the previous one. Second, that an individual subject describes the system. Third, that the state is a representation made by the subject based on the knowledge she has about the system. This has two important consequences. First, the state is observer-dependent, and second, as different psychological subjects may have different knowledge and expectations about the same system, they may represent it using different density matrices. Therefore, the subject's representation cannot be neither ontological nor epistemic in the classical sense. 4. That observables in postulate 2 do not commute. 5. That Born's rules makes the theory to be essentially probabilistic. This probabilistic character means that the result of a measurement is not contained in the formalism. It cannot be predicted in general with certainty in terms of a physical interaction between the system and the apparatus. Quantum theory renounces all attempts to concoct a concealed mechanism with which to explain a particular result. The results appear as acts of creation located outside the theory. Sixth, that the change in the state the collapse of the four postulate, is due to the fact that an individual subject has observed a result and her information has changed. This change is then instantaneous. It occurs as it is observed by the individual subject. Note, however, that if not finally shared, information changes in individual subjects become irrelevant for science. The information communication, to say to others what we have learned, appears as an essential element of the theory. Therefore, the change of information must take place eventually in the scientific community, in what we will call later on the transcendental subject E, making so that this new fact become part of physical reality. An understanding of nature coherent with the previous ideas must incorporate, first, the observer dependence of the theory. Second, locality. That is, that the subject cannot move or communicate at superluminal velocity. Third, the non-commutation of observables. One of its most important consequences is that the values of properties that we get as results in an experiment are in general not connected to pieces of matter. If you try, anyway, you could get the contradiction +1 equals to -1, as all you know perfectly. Therefore, realism, in the restricted sense, is incompatible with quantum theory. 4. That observations require observers. 5. That measurements are acts of creation of magnitude values. Each event is random, yet alters the probability of later events and so of the future. 6th, irreducible randomness. 7th, realism in the broad sense. 8th, causality in the sense that it is not possible to act on the past. And 9th, that the individual subject that gets the results is a necessary intermediary of the transcendental subject E that builds up physical reality. Now, based on these ideas, I will try to introduce a conception of the world in a first approximation. In two parts. In part one, I will introduce first what I call a general ontological matter, M, or material reality, understood as a plurality with three different genres, M1, M2, and 3, that could be related respectively with corporeal, psychological, and the world of theories and critical arguments, with Popper theory walls, for example. Implicit here is a distinction between corporeal, belonging to M1, and material, belonging to M. All that is corporeal is also material, but not all that is material is corporeal. The objects in classical mechanics are corporeal and material, but it's not always the case. Besides the material reality with its three genres, I will introduce a network of relations between the three genres called the symploquet and a transcendental subject E. In brief, I have to introduce the complex M, Mi, E, and the symploquet. This idea has been taken from my colleague Gustavo Bueno. The transcendental subject E must be seen as an activity that occurs at the intersection of the three genres of materiality. It is not an individual subject receiving the stimuli of a transcendent and detached world. That subject does not exist outside the world. E is the very practice of social historical nature in which the world, physical reality, is constituted as object. The provenance of the symploche idea is related to the possibility of knowledge. I suppose you know it, but I will explain it briefly. Plato was perhaps the first one in perceiving that Parmenides' being cannot be unique. The genesis of his thought about the symploche could have been that all cannot be related with all, because in that case knowledge would be impossible. To know about something, you would have to know everything, an impossible limit. And Plato also thought that if everything were independent of everything, we would have again a situation in which knowledge would be impossible. It would be the chaos. Any order would be equally possible and arbitrary. What made knowledge possible is precisely that not all is related with all, and at the same time that all is not separated from all. What made knowledge possible was called by Plato the symploche. The symploche could be then understood as the web of relations among things when the emphasis is put on the moment of the connection and also in the mutual partial independence between the terms included in the symploche. In other words, in the symploche, the whole contains more than the sum of its parts. Introducing a bold physical analogy, Plato's symploche evokes entanglement. Symploche see as the interwave making knowledge possible, and entanglement as the interwave making possible quantum information tasks. Part 2. Material and physical reality, the role of the subject. I will introduce now a distinction, partially exercised before, between material reality, which includes its genres that do not exhaust material reality, and the relationships and physical reality. In physical terms, material reality could be analogically understood as the Dirac substratum. According to Dirac, the fundamental laws of nature, as stated by non-relativistic quantum theory, do not govern the world as it appears in our mental picture in any direct way, but they control a substratum on which we cannot form a mental picture without introducing irrelevances. Meanwhile, physical reality is a social construction built up by the transcendental subject E, based on the joint product of the evidence that is available to those who communicate, that is, eventually based on our present laws and theories. The structure that we designate as nature, participatory realism, physical reality of the world, is precisely the construct built up by the transcendental subject E. This entails that what is known by E exists and belongs to physical reality, and that what can be known becomes part of physical reality when it is incorporated to the common heritage. In particular, this implies that we derive knowledge about the past from present evidence. When new results of observation change our shared information, we modify accordingly what we can say about physical reality. In the words of Weizsäcker, what is observed certainly exists. About what is not observed, we are still free to make suitable assumptions. This freedom is then used to avoid paradoxes. The suitable assumptions are made based on the information that we are getting now, even if our current theories tell us that the observed event occurred millions of years ago. These past events were called anonymous measurements by London and Bauer. Anonymous measurements are not spontaneous observations. They are not even observations. Observations require observers learning information and updating the state. Anonymous measurements become part of physical reality only when they are incorporated by the transcendental subject. physical reality is being continuously elaborated by the transcendental subject. In other words, it is wrong to think of physical reality as already existing in all detail. Physical reality is theory. By deciding what questions our quantum registering equipment shall put, we have the undeniable choice in what we are the right to say about physical reality. From this perspective, for example, the bogus paradox introduced by Bell with the universe standing still until a PhD conscious observer evolves to collapse the wave function becomes absurd. She does not need to be there to physically collapse anything. The collapse is not a physical process. Learning information and not an interaction is what induces the collapse, creating a new future. The past is also constructed by the transcendental subject using no contradictory present evidence. Note that in this framework, there is not isomorphism between material and physical reality. That imagined isomorphism is a peculiar characteristic of the transcendent realism due to the fact that in classical physics, the individual subject could be eliminated. This allows us to speak of a detached physical reality as if it were given in our absence, or as if it were a book open in front of us. If the isomorphism were the case, the resulting view should be definitive, impermeable to any intellectual transformation. It would be the end of our endeavors. Unfortunately, this is not the case. Quantum mechanics tell us that the object of sciences, physics in particular, is not to make an image reproducing material reality in its minute details, a paradoxical one-to-one mapping of the unknown, but to help us to put order in our experience building up physical reality. In the well-known words of Niels Bohr, in our description of nature, the purpose is not to disclose the real essence of the phenomena, but only to try down, as far as it is possible, relations between the manifold aspects of our experience. Classical mechanics was formulated putting the emphasis on the corporeal elements M1, segregating the individual subject. The elements of M2 and M3 and part of the complex network of relations between the three genres were minimized or forgotten. The reason is well known. In classical physics, the physical magnitudes and their functions are represented by C numbers, and C numbers commute. Therefore, you can assign definite values to all physical magnitudes of a system at any time. The result is that the individual subject could be eliminated. Due to this concrete fact, we can say that EPR elements of reality exist here and that the theory is directly ontological and representational. Although quantum classical mechanics was built up from the perspective of a first person, as any other human activity, and I coincide here with Peter Putnam, although I didn't know before 1 hour ago, as any other human activity, the segregation of the subject allows a third-person perspective, that is, as if physical reality were detached. However, this contrivance cannot be done again in quantum theory. In quantum theory, the physical magnitudes are represented by Q numbers, operators that in general do not commute, and not their functions either. As a result, the values are only predictable with some probability. They do not pre-exist, and therefore they are created in the measurement. The individual subject cannot be segregated. She becomes essential, and her actions matter. It is true that the observation could be done in a first instance by a registering device. However, this result is scientifically irrelevant. It would be an anonymous measurement, and anonymous measurements are no observations. They do not exist until an individual subject, as part of the transcendental subject, knows it, and afterwards it makes it public and so on. For this reason, physical reality related to quantum mechanics cannot be seen as detached. It's not, and it has never been. Our proposal is to build up a conception of the world based on the metaphysical framework previously introduced, that is, incorporating the complexity contained in the triad MMI-E. This proposal could be succinctly summarized as follows. Since the midst of time, humans have interacted with the environment. The manipulation of the environment over millions of years gave rise first to pieces of matter and then to physical objects, seen here as the result of a long process of efficient interaction with the environment done for survival purposes. The subsequent manipulation of these material objects established relationships. These relations were, in turn, used to build up new material objects and then new relations and so on. Let us put a very naive example based on two images to briefly illustrate what I mean. The three drawings in the figure are two-dimensional and may have no significance as a whole. But when we introduce order by composing them, as you can see in figure 2, we build up an object with volume in a three-dimensional space. When the drawings are disordered, they are undifferentiated parts of material reality. But when we physically manipulate them, they turn, through the process explained above, into the illuminated sphere that we perceive today. A second example could be the sun. About 5,000 years ago, in Mesopotamia, or in the Egyptian Old Kingdom, it was a god. This view changed in the ancient Greece with Plato and Aristotle, who saw it as a celestial object, perfect and immutable, that move around the earth in a circle. In the 16th and 17th centuries, Copernicus and Galileo changed once again that vision. The sun was not any more perfect and immutable, and so on. To abbreviate, in the last 200 years, our conception of the world has changed dramatically, and today it is still changing every year and every month as we get more information. The object, the sun in this case, is not invented by the transcendental subject. It is built up on mankind's experiences. The sun is all those experiences, past and present. Of those experiences, the past ones cannot be undone. Although the strict application of quantum mechanical rules could suggest the contrary, as Mermin told some years ago, it is true. The moon is there even if nobody looks at her. The moon is also all those past experiences that cannot be undone. So we know for certain that it is there. Any other object in physics, biology, art has been subject to similar processes to finally get its actual and perishable meaning. To make a long story short, in each historical period, we elaborate not on the thing in itself, but on objects and concepts inherited from the previous generations, in the last instance from our ancestors, involving millennia of evolution for survival. And although our knowledge comes ultimately from material reality, from a substrate that we don't know what it is, it has always had this anthropic component. Summarizing, it can be conjectured that through analogous processes, undifferentiated material reality gave way to physical objects as postulate entities which simplify our account of the flux of existence, and later to relations finally abridged in a certain algorithm able to reproduce all relations of that class. This algorithm is what we designate as a natural law, but the scientific laws appear here not as unalterable laws of nature, but as rules of actions on things. It was this everlasting intervention in a malleable nature that shaped our world, introduced order in material reality and mental evolution in human beings. History of mankind, and therefore the history of sciences, appears in this framework as a history of simultaneous constructions on the object on the one hand and of the transcendental subject on the other. Note that as far as material reality is concerned, the order introduced is not arbitrary. Not everything works. In fact, the result of any process is independent of our will. Material reality has its own legality, revealed by its resistance to some of our operations, by the fact that some of these operations work and others do not. Those that work show invariants, regularities that finally we express in laws. This approach allows us to understand why the classical transcendental methodology worked so well in the past. As I have said, it refers only to those situations in which the individual observer could be removed completely. Then the phenomena were explained as if the result were given in our absence. But quantum theory reminds us that the individual subject is an essential part of the process, and that the procedure is just the opposite. It is only once we have concrete objects, laws and theories that we can reverse the process and contrive how the world would be in our absence. But this reconstruction requires ineluctably the intervention of an individual subject that has never been a detached observer, but an active agent trying to survive, solving all problems with new methods and new problems with creativity and imagination. Perhaps you are thinking now, how does the ideas of objectivity and truth enter in this framework? In the classical mechanist conception, the truth is what naively seems to be, the correspondence with the object. However, from our point of view, correspondence does not exist. Where and how do then the cherished objectivity and true ideas enter in our theories on this conception? The concept of scientific truth without correspondence, related with the conception outlined here, should satisfy two conditions. Namely, it must be useful in any field of human activity, and it must incorporate the fact that the scientific construction finishes at the edge of human experience. In this approach, the concept of truth is established by what I call a confluence. A confluence is produced when, using different and independent empirical processes, we inexorably reach the same result. Independent means that one of the processes could be experimentally refuted without the others being necessarily so. Confluence requires the convergence of various regularities. For example, the determination of Planck's constant can be done based on many different independent research programs. The black body radiation, the photoelectric effect, the Frank-Hertz experiments, the X-ray production, and so on. When these experimental determinations are done, it is found that within experimental errors, the regular result obtained in each independent processes converges in the same value for h. This confluence establishes forthwith the consensus inside the physicist community, materializes the quantity h, and from this point on, it can be said that h is a truth of physics. We could argue similarly in many other cases. For example, in the Avogadro constant is determined for more than 40 different and independent methods, and many other cases, as I said, to the point that these confluences processes are the general manner of establishing the concept of truth in all human activities. It is a historical fact in physics that whenever the same result has been reached by 3 or 4 independent means, it has never been overturned. These confluences, besides being permanent, are objective. It is not in our hands to make them converge or not. That is, they cannot be manipulated by the desires of an individual subject or a community. A representation in which some confluences are depicted by some small iron pots may be seen in the following figure. Besides getting these confluences, what the transcendental subject does is interrelate those iron pots with many other data and information into a coherent body, creating a possible arrangement called physical reality or participatory realism, as this figure metaphorically suggests. Although introduced with different purposes, I should remember at this point 2 interesting anticipations that have served as inspiration for my work. The first precedent is the famous metaphor of the piles in the swamp introduced by Popper in his seminal work. Popper says, "Science does not rest upon solid bedrock. The bold structure of its theories rises above a swamp. It is like a building erected on piles. The piles are driven down from above, but not down to any natural or given base. And when we cease our attempts to drive our piles, it's not because we have reached firm ground. We simply stop when we are satisfied." The second precedent is Wheeler. He writes, "What we call reality consists of a few iron posts of observation, among which we fill in by an elaborate papier-mâché construction of imagination and theory," adding the figure that I have used. The essential difference between Popper's proposal and my proposal is that, on the one hand, confluentism might involve different theories, and on the other, maintains a stronger relations with material reality than the one manifested by Popper. Confluences seems to reach material reality, firm ground, although only in a few points. As far as Wheeler's proposal is concerned, I don't really know. The use of the word post of observation suggests that he is not speaking about confluences. However, this clue is not enough to reach a definite conclusion. Confluentism shows that there is something epistemologically special about the nature of scientific knowledge. It allows maintaining contact with material reality, as well as holding that physical reality is a social construction, as Richard Rorty, of the sociologist of the Strong Program of the Edinburgh School, maintains. What seems to have misled these authors about scientific knowledge is the fact that this same procedure is used not only in physics, sciences in general, but in all our activities as well, like jurisprudence, psychology, history, or medicine, to name but a few. However, the big difference, not considered by them in all its relevance, is that in physics, an appeal to the resistance of matter is realized, Nevertheless, this is all that is needed. Thank you very much for your attention.
What's the relation between the experiences or observations of the individual agents and the individual subjects and the transcendental subject? And in particular, is there anything in your theory that would lead you to, or that would guarantee that there is consistency between the individual subjects and consistency between the individual subjects and transcendental subjects?
Well, the individual subject makes an experiment. Let's think about an Sten-Garland experiment, and he gets a result. He didn't take note of the result and went away to have a coffee. A car crashes him and he dies. What about this result? I call it an anonymous, London and Bauer call it an anonymous measurement. It has any relevance. It's not really an observation. The observation requires that this result is made public, and the role of the transcendental subject can be seen through, let us say, this publicity. I mean, the society has universities, has institutions, has journals, and so on. There is a complex tissue of institutions that makes that the transcendental subject can work. I say it's a social activity, and we have institutions to allow this activity. I don't know if I have answered your question.
Michael. So if I kind of for a short comment and then also a question. So I guess they're a little related. I mean, so at the beginning you said something. You said something to the effect that classical theory has been refuted. And okay, so in some sense, I guess that's true. But it seemed to me that you were conflating. To me, that you're conflating two things. On the one hand, you have classical physical theory as it's developed by Newton, Maxwell, and many others. And on the other hand, you have what, let's say, Bohr would call everyday classical concepts of like, something's located here at this time, some things dynamically interact with one another, causing in some sense. It doesn't follow from I would say that it doesn't follow from the fact that classical physical theory is refuted, that the everyday conception is refuted. So it's not necessarily a reason to reject the everyday conception that we now have quantum theory. I would just say that. The question, so maybe you can respond to that, but the question I had was, later on you mentioned how physical reality is in part constituted by our theories, and so as we develop new theories, these become embedded into physical reality in some sense, if I understood you correctly. So what happens when a theory is refuted? Does physical reality get diminished? And if it doesn't get diminished, then could you say something in what sense there are truths from classical physical theory that are maintained, and how are they maintained?
With respect to your comment, I agree. But I was speaking about that. What I say is that classical physics has been refuted and, was unable to explain a lot of experiments. So it was empirically refuted. And an empirically refuted theory cannot be the basis to build up any coherent conception of the world. Has been refuted. I mean, and I say that of course, classical mechanics is useful only for practical purposes, for our common life. You cannot, the idea that we have today of the universe is given by general relativity. Physical reality has changed. When a refuted theory, when a theory is refuted, the conception is re-elaborated. I also say that. It is a continuous construction of the object of the world and of the transcendental subject. There is a mutual interrelation. All this has been done by us. This is my position. And what was the question?
Yeah, so I mean, if classical physical theory has been refuted, then does physical reality get diminished?
No, I did. I answered this. It changes also.
Changes.
Yeah. Well, I was trying to pick up the slide, but I think that I have answered your question, or not.
Chancellor? So I guess I have a problem with this distinction between private and transcendental knowledge.
Sorry?
I have a problem with this distinction between, I'm not sure how you call this private or individual and transcendental knowledge. In your reply to Rudiger, for example, I mean, I can imagine that although the observer was killed in this car accident, there are traces of this outcome.
Of course.
It's kind of classical information. And now I can imagine that maybe the detector was heated to that extent that it damaged a cable, and which will lead to the great fire with great consequences for all of us, for our public. And so I feel there the tension, and I could not know even in advance when such information will be kept private or could be maybe distributed, even in a violent sense. So I don't know whether you...
No, I can't. This is the same problem, more or less, as has the tree fallen in the forest when nobody was there? Was Hume, or I don't know, the first one to put this question. If nobody is there and you use quantum mechanics, there is no observation. Observations, from my point of view, observations require observers. So, who knows? The answer is not. But well, I'm not finding it. Anyway, I will answer you. This is an anonymous measurement. Until an individual subject knows it, then it has again an accident and dies. It goes on being an anonymous measurement. 100 years later, someone goes to the forest and measures and determines that a tree has fallen, makes publics and so on, and we change our knowledge, and a tree has fallen. This is all.
Richard, had a question?
Yeah.
Richard?
Yeah, my question concerns your notion of a transcendental subject.
Yeah.
And when you first introduced this notion, I thought you meant just the set of individuals, or in particular the set of inquiring scientists. But it wasn't clear to me that that was all you meant by it, because at one point you also called it an activity, which is not the same thing as a set of individuals. And then to call it transcendental suggests that it's somehow something more than that somebody cannot be reduced to just a set of individuals. So what exactly is a transcendental subject?
Well, you must consider the complexity contained in a triad M, Mi, and E. So, between the genres of the material reality, there are interrelations, there are relations. All this is incorporated in E. So E is not the ensemble of individuals.
Does it include the ensemble of individuals?
Include the ensemble and individuals and all the relations between the genres of materiality.
It's not an activity.
It's also an activity.
I can't understand that. How can it be also an activity if it is a set of individuals plus the relations among them? Then how can it also be an activity?
The transcendental subject is also an activity. An activity, I say, is more than the sum of the individual subjects, because it includes the relationships between the genres. Right. But it also includes the ensemble of individuals and its activities.
Oh, okay. So it includes activities. It is not an activity.
Includes activities.
Okay, good. That's clear. Thank you.
Any other questions? Chris?
So I'd like to try and restate Mike's point, because I don't think your response to it was adequate. So let me try putting it this way. So Mike was worried that, notwithstanding the falsity of detail, particular classical physics, there might be something left which might form part of a perfectly reasonable metaphysical package for developing a view, perhaps incorporating quantum theory. So in your story, we arrived at a particular kind of philosophical view, what you call traditional realism, on the basis of the success of classical physics. But one might see things as going the other way around. You might say that we come in with a certain kind of semi-articulated metaphysics of the world, which sees our role in it as fairly derivative. We poke a few things around, but we don't make the world. We're part of the world, and we respond to it in various kinds of ways. But we don't play an important constitutive role. We come with that and construct classical physics on the basis of that. Turns out that the details of that theory didn't work out, of those theories didn't work out. Then we move to quantum theory. Are we forced to move away from that pre-theoretic folk metaphysics, if you will? Well, no, we're not. There exist perfectly logically coherent, straightforwardly realist interpretations of quantum theory. So we can't just say that metaphysical picture is wrong because detailed classical physics is wrong. And we can't just say that metaphysical picture is wrong because there's no other way of doing quantum theory than rejecting it, because such ways exist. I think we have to admit that if we want to reject that previous kind of metaphysics, it's because we're exploring other options to see if overall their package works better. But there isn't any kind of knockdown argument, so far as I can see, which says that one can't stick with the, broadly speaking, pre-theoretic, pre-classical physical metaphysical conception.
Is that a comment or a question?
So that's a comment. So I was restating Mike's concern and just saying that a false theory is no basis on which to develop a detailed metaphysics is sort of irrelevant to the question of what metaphysics we ought to have. So do you agree, let me put it as a question, do you agree that one way of thinking about things would be that classical physics arose from a pre-theoretic metaphysics rather than vice versa?
Difficult question, isn't it? I don't know, really. Perhaps they were articulated at the same time. I don't know.